We emphasize the key role of Scalable Vector Graphics or SVG coding activities within our approach, highlighting their integration with Montessori's 3D geometric solids. Starting the ages of 3 to 6, children are in an extremely formative stage of development, not just physically, but cognitively too. Dr. Maria Montessori referred to this phase as the Absorbent Mind stage, characterized by a sponge-like ability to absorb knowledge from their surroundings. In this stage, sensorial experiences are crucial to learning, making the Montessori 3D geometric solids an invaluable resource. These tangible objects provide not just enjoyment, but significant educational benefits as well. The journey from engaging with Montessori 3D geometric solids to SVG coding can be considered a progressive shift from tactile, hands-on learning experiences to more abstract, digital ones. The transition may unfold in the following way. 1. Understanding shapes and their properties. Children initiate their journey by manipulating and exploring the Montessori 3D geometric solids. This allows children to identify and comprehend the properties of various shapes, laying the groundwork for understanding basic geometry in a visually immersive and tactile manner. 2. Bridging real-world objects with geometric shapes comes next. Children start connecting these geometric solids with objects in their surroundings. Recognizing geometric shapes in the physical world strengthens their connection between abstract concepts and real-world applications. 3. Transition to 2D representations. Upon gaining a firm understanding of 3D shapes, children are gradually introduced to their 2D representations. Activities like drawing, shadow tracing, or crafting paper models can facilitate this shift, enabling children to comprehend how a 3D object can be symbolized in 2 dimensions. 4. Venturing into digital representation of 2D shapes. When children are comfortable with 2D shapes and their representations, they can then be introduced to digital platforms that allow them to create and manipulate 2D shapes. This pivotal step guides children from physically manipulating shapes to digitally handling them. 5. Stepping into SVG coding. Once they are familiar with digital representations, children are gradually introduced to SVG coding using a customized SVG sandbox jointly developed by Tokyo Blockchain Academy and Learn India. Starting with coding simple shapes, they progressively take on more complex shapes and designs. This learning phase allows them to digitally manipulate shapes, acquiring knowledge about attributes like coordinates, size, color, and transformations. 6. Advancing SVG coding. As children's comfort with and proficiency in SVG coding increase, their interests are stimulated by more challenging tasks. These include creating animations, coding intricate shapes, and even delving into basic concepts of trigonometry and algebra. Through this step-by-step progression, children transition from a concrete understanding of 3D shapes to the abstract realm of SVG coding. This seamless shift from Montessori geometric solids to SVG coding not only enhances their grasp of mathematical concepts but also cultivates digital competencies. In the process, SVG sandbox coding activities provide a platform for the development of foundational mathematical concepts as follows. A. Cartesian coordinate system. In SVG coding, children learn to position elements using X and Y coordinates. They, for instance, place a square at coordinates 10, 20 and observe how altering these values changes the square's position. This practical application aids in understanding the Cartesian coordinate system. B. Geometry. As children create and alter geometric shapes using SVG sandbox coding, they acquire hands-on experience with geometric concepts. They might code a circle and modify its radius, observing the effect on the circle's size. This could lead to calculations of the area or circumference of the circle, reinforcing their understanding of these concepts. C. Ratio and proportion. SVG scalability introduces the concepts of ratio and proportion. Children create a rectangle and then scale its width and height, observing how the rectangle's visual representation changes while maintaining the same aspect ratio. D. Transformations. SVG coding allows children to perform transformations on shapes, such as translation, rotation, scaling, and reflection. They code a triangle and apply a rotation transformation, observing how the triangle rotates around a specific point. This practical application assists in grasping these fundamental geometry concepts. E. Trigonometry. For more advanced learners, SVG can serve as a platform to explore basic trigonometry concepts. They code a polygon, calculate its interior angles, and observe the relationships between the angles and sides of a polygon. Rotating elements and observing the impact of rotation on the element's position provides a tangible experience of trigonometry. F. Algebra. Creating animations or complex SVG drawings might involve the use of algebraic expressions or functions. Animating a circle to move across the screen based on a quadratic function provides a real-life application of algebra. G. Problem solving. SVG coding encourages logical thinking and problem solving. For instance, a task involves creating a specific image using a combination of shapes. To accomplish this, children need to apply their mathematical knowledge strategically, think creatively, and solve problems as they arise. Currently, we are in the pioneering phase of integrating SVG coding into the preschool curriculum, laying a foundational understanding for our young learners. As we refine and adapt this innovative approach, our intention is to extend the application of SVG coding into the elementary and high school stages. The goal is to create a continuous, progressive learning pathway that seamlessly connects these different educational stages, fostering a deep and sustained engagement with technology throughout a student's academic journey.